Hello. Today I'd like to talk about arrays in Odin and the different types that are available. Um, let's actually start with the most simple type of array, which is this same as you would have in C. Um, and that's just a constant array, constant size array. So if we do something like this, right? We do my array of type this, and we'll give it a value of, I don't know, 1, 2.5, 3.6, 2.7, something, right? This array lives on the stack, meaning no allocations happen when you do this. It's just on the stack. And it's a pretty nice way to do um, vectors and stuff. So let's say you wanted to take in a something that took in a position like, I don't know, offset position, and you have a proc, it takes in something, and then it takes in the position, you know, it's called offset. You would be able to do something like this, and maybe a vec free, and you would be able to treat this like a vector. So this would be a vec2, a vec3, a vec4, so on and so forth. Yeah, very useful. Uh, Maybe not the most common type of array, but yeah, the most common type of array would probably be something like the slice. So yeah, let's just write here that this is a constant, and this we call a slice. So what is a slice? Well, a slice is a array that lives on the heap, but you're unable to resize it. Um, so to make a slice, you would do something like this. And yeah, we don't need the type here. That's optional. So now the array is a slice of F32s, and it has a length of 10. It's pretty useful. You know, you can allocate it dynamically. So this is not a constant, unlike the other one. This could be my array size, and my array size is some variable that get passed in here or something. All right, then we have dynamic arrays, and the only difference is that you write dynamic here, and when you do this, it's no longer unresizable. You can resize the array, which makes it dynamic. Um, when you do that, there's one thing you have to look out for, and that is in this make function, this first thing is not the length, it's the capacity, and the next thing is the length, right? So yeah, and we call this a dynamic array. Um, I want to mention something here, and that is you can convert dynamics arrays into slices. So if we say my slice, and that is of F32, and yeah, we want to pass this or convert this my array into a slice, you just do this. You just write a colon, and that means take everything in the array and convert it, or yeah, take everything in the array and use it in the slice. You can also offset from both sides. So let's say 5. This means goes from index 5 and forward and put it into the slice. This means goes from 0 to 5 and put it into the slice. This means go from 3 to 5 and put it into the slice, so on and so forth. It's borrowed from Python, I believe. So yeah. And then you have this last type of array. Oh, let me just mention something here. If this is a constant size array, so let's do like this for F2s, you can still do this, right? So the reason why we have the slice is to be a common interface between both being able to pass constant and dynamic size arrays. And yeah, when you do this, this just points to the stack. it doesn't copy anything. And the same with the dynamic, it just points to the data in the dynamic array. Yeah, and the last point or array type here is when you interface with C, and it's equivalent to just a raw pointer, or actually not really. It's equivalent to a pointer to add an F32. The only thing is, if you wrote this, you wouldn't be able to index it. You would get a syntax error. But if you specify that, hey, it's actually an array, but I don't know the length, then this becomes valid, and you're just responsible for not stepping over the boundaries of that array. And so this is basically how arrays in C work. So yeah, that's all for this video, I think. So good luck.